So homework 31, we're starting chapter 6, which is all about factoring. So factors, when you think of factors, you want to think of what times what gives me that answer, right? If I think about my factors of 12, 1 times, oh, I'm on the wrong pen again, I better close this and try that again. Otherwise it won't let me erase. Did that to me this morning. Let's see. Smart ink. Now it's on Smart Ink. Now it'll let me erase. So factors of 12, 1 times 12, 2 times 6, and 3 times 4. Those are all of your factors of 12. 35, we'd have 1 times 35. 2 doesn't go in there, 3 doesn't go in there, 4 doesn't go in there, but 5 does, so 5 times 7. Well, if I'm looking for my greatest common factor of 12 and 35, you can see that they don't have much in common, do they? The only thing that those two numbers have in common would be the 1. So my 1 is the greatest common factor. So when you're thinking about greatest common factor, you're thinking about greatest. What's the biggest number that's common, or to both of them, that's a factor of both of them? You could list all of the factors, but a lot of times you could just think of what your greatest common factor is. If I have 12 and 34, what's the biggest number that divides evenly into both 12 and 34? 2. And if I have 15 and 45,
5.
There's a bigger one than 5. 15, because 15 does divide into 45, so 15 happens to be the greatest common factor, since it's a factor of itself and a factor of 45. So that's going to be way back in that dark green section. There was a couple topics it wouldn't let you get to. That's going to be way back at the very beginning. Now it should let you in there if you haven't already gotten that right on the assessment. So what they really want to get into then is when I start throwing the variables in. If I'm going to do the greatest common factor of something with a variable, if they have the same variable, you're going to use the lower number. If I have an n and an n to the second, well, this term just has 1 n, but this one would have n times n, 2 n's. Well, they only have 1 in common. So my number, I just do the normal way. Greatest common factor of 12 and 15 would be 3. The greatest common factor of n and n to the second, I use the lower amount because you can't have more than you have. And so 3n would be my greatest common factor. Now number 5, when they did the greatest common factor, we still have the greatest common factor of 15 and 12 being 3, but since the variables aren't the same, they don't have anything in common. So in that case, you just have a number that's your greatest common factor, just the 3. And she picked out some really good ones. And so if I'm finding the greatest common factor of 10n squared and 11x to the 4th, which is on the top of the next page, the greatest common factor of 10 and 11 is 1. And again, the n and the x to the 4th don't have anything in common. So I just get that greatest common factor of 1. No variable with n.
Because the variables are different?
Because the variables are different, so they're not in common, right? They wouldn't have anything in common. We'll get to some longer ones.
Yeah, obviously.
So, if I'm doing the greatest common factor of 24w squared u to the 7th and 18w squared u to the 6th b to the 18th, I'm first of all thinking of my greatest common factor of 24 and 18, which would be 6. Then when I look at my variables, here I have a w squared, here I also have a w squared, so they have a w squared in common. Here I have a u to the 7th, here I have a u to the 6th. So my greatest common factor there would be u to the 6th. And even though I have a v here, I don't have any in the first one, so of course they don't have that in common. So 6w squared u to the 6th would be my greatest common factor. So number 8, we have 12y x squared and 30y to the 4th u to the 3rd x to the 6th. My greatest common factor of 12 and 30 is 6. If I have a y and a y to the 4th, the y. If I have an x squared and an x to the 6th,
squared.
the x squared. And again, even though that one has a u, the first one doesn't, so we can't include that because it's not common to both of them. So number 9, if I have 20y to the 7th, w to the 4th, x to the 3rd, and 12y to the 8th, x to the 3rd, my greatest common factor would be
4.
4, y to the 7th, and x to the 3rd. So factors are usually less than or sometimes equal to what you have, right? Because if they're the same, then it can be equal to, but otherwise I got to do less.
Let me write that. Factors are
Less than or equal to your values. Yep, they can't be bigger than your values if you're doing a factor. So the reason they talk about the greatest common factor is because when you factor an expression, you're trying to figure out, well, what times what gives me this answer? And the first thing you should look for is there a greatest common factor? Is there something I can divide out of both terms? Well, sure, on this one I can divide them both by 5 and
3. No.
on your variables, a b. So 5b is my greatest common factor. We're going to put that in front, and then we're going to put parentheses, and then we're going to divide that out of each term. If I take 15b to the 2nd and divide it by 5b, I would get 3b. I divide my coefficients, I subtract my exponents. 5b times 3b is 15b squared. Negative 10b divided by 5b would be negative 2. Negative 10 divided by 5 is negative 2, and b minus b is 0 of them left, so I don't need any extra ones, right? So factoring what times what would give me this answer. If I take this times this, I get that. This times this, I get that. So number 11, if I want to factor that one, my greatest common factor would be 1 w squared. So if it's 1w squared, we can just write it as w squared, right? 1w squared and w squared are the same thing. So if I have 4w to the 3rd and I divide out a w squared, what would I be left with? 4w. I'm subtracting my exponents. 3 minus 2 leaves me that extra 1 in there for my w. And if I have 13w squared and I divide it by a w squared, just leaves me the 13. So that w squared times 4w squared is 4w to the 3rd, and w squared times 13 is 13w squared. Hey, yes it is. So number 12, I want to factor that. My greatest common factor is 3a squared. So when I divide out my 3a squared, 12a squared divided by 3a squared is just a 4. And negative 9a cubed divided by 3a squared would be negative 3a. By the way, when you have this, you want to make sure you don't have anything left in common. In case you didn't get the greatest common factor out, if you looked and said this was 4 minus 8a, you'd say, oh, those are both divisible by 2. I should have taken out a bigger number. So then they did the short ones. Now, of course, they get the little longer ones. If I have 12u v to the 2nd, y to the 6th, minus 28u to the 8th, v to the 8th, my greatest common factor, if I have 12 and 28 would be 4. And then I can take out a u and a v squared. Can't do y's because there's not a y common to both. So again, just thinking about I'm dividing my front numbers, subtracting my exponents. So 12 divided by 4 is 3. 1 minus 1, no extra u's. 2 minus 2, no extra v's. But I still have that y to the 6th, right? So you always double check and say, okay, if I take this times this, would I get this? 4 times 3 is 12. I've got the u, the v squared, and the y to the 6th. And then negative 28 divided by 4 would be negative 7. U to the 8th, I took out one of my u's, so that'd leave me a u to the 7th. V to the 8th, I took out a v squared, so that'd leave me a v to the 6th. 4 times negative 7 is negative 28. U times u to the 7th is u to the 8th, and v squared times v to the 6th is v to the 8th.
Oh boy.
So I subtract my exponents. You ready to try, Christy? So 14 says 24 u to the 6th x squared y to the 3rd plus 4 u to the 9th x to the 8th. My greatest common factor would be 4 and then my variables. U to the 6th, exactly.
X squared.
And x to the 2nd. Right? Because they both have x's, and so I take out the lower number.
No Y's, so you don't do that.
And they don't both have y's, so I can't take a y out, right? So, now I have to divide. When I divide, I'm going to get 6y to the 3rd. See how she got that? Plus 1. You don't really need to write the 1 unless there's nothing else left over.
This is where I'm going to get u to the 3rd?
Yep.
Okay.
And
X to the 6th?
x to the 6th.
Because you're subtracting them?
Because you're subtracting them, right. Remember we did those ones where we had like x to the 8th over x to the 2nd? And x to the 8th, we had 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. And x squared meant you had 2, and we took off 2 of them, left us 6. So that's what we're doing, is we're saying, oh, if I had to write this out the long way, there'd be 8 of them on my list. There's only 2 here. That means I need 6 more. All right. And number 15. Brianna left, so you could do that, this one.
3?
So 3.
U to the 3rd?
U to the 3rd.
W to the 5th?
W to the 5th, exactly. Can't do the y's since there's not a y in both of them. So now if I divide that out, I'm going to get
3. U to the 4th?
mm-hmm,
W to the 2nd?
yep,
W squared plus 10. U to the 3rd is good, so we don't need to put that there?
right,
Okay. W to the 5 is good, so then just y to the 4th.
exactly. There it is. Those should be the first 5 things in the factoring section of your pie chart. Get you something to practice.